The last clip was interrupted. The program malfunctioned. So we didn't get the very last part of it, but I'll fill that in right now and then we'll move on. So we're looking at the behavior of the cosine of omega naught t plus cosine of omega 1t expression from the solution. And I mentioned that people don't generally remember the formula for cosine of theta 1 plus theta 2. It's easy to construct the formula. I'll confess that I don't remember the formula from time to time if I haven't used it recently. But I know that I can always reconstruct it in 30 seconds or less by simply remembering Euler's identity. E to the I theta equals cosine theta plus I sine theta. This arises by simply considering the Taylor series of e to the I theta, Taylor series of cosine theta, and the Taylor series of sine theta. Basically, if you write out those three Taylor series, this identity just about pops out at you, and hopefully that's something, at least you've seen the Taylor series in calculus, first year calculus. It's a standard topic, and you don't need a whole lot of Taylor series to be able to understand this. So hopefully you've seen that, and hopefully you've seen this identity and how it's derived. Whether you do or not, there's the identity. And if we apply this identity just to the angle theta equals theta 1 plus theta 2, it implies the following. E to the I times theta 1 plus theta 2, of course, is going to be the cosine of that angle, theta 1 plus theta 2, plus I times the sine of the angle, sine of theta 1 plus theta 2. By the laws of exponents, e to the I theta 1 plus theta 2 equals e to the I theta 1 multiplied by e to the I theta 2. And if we write out what e to the I theta 1 and e to the I theta 2 means, we get this expression and this expression. Now, if we multiply these two expressions together, what we get has to be equal to what we get up here, since this is equal to this. Which means that the real part of our product has to equal the real part of this product, which is cosine of theta 1 plus theta 2, and furthermore the imaginary part of this product is going to equal the imaginary part of this expression. It's very easy to see what the real part is. Cosine of the real part is going to be cosine theta 1 cosine theta 2, which is what I wrote down here. And the imaginary part is going to be I sine theta 1 multiplied by I sine theta 2, which is negative sine theta 1 sine theta 2, which comes up here. The imaginary part gives us the identity for the sine of theta 1 plus theta 2. And the imaginary part is what? It's I sine theta 1 cosine theta 2 plus I sine theta 2 cosine theta 1. Take the I away and you get the negative sine theta 1 sine theta 2. I'm sorry, you don't get that. You get the sine of theta 1 plus theta 2, which is going to be sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2. Now I'll just kind of leave this as a diversion and go on to another video clip where we're going to apply this to analyze this and make some sense out of this.